Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2270, indicates an issue with the secondary heated oxygen sensor, HO2S, also referred to as Sensor 2, in the Honda CR-V 2023 and newer models. This particular diagnostic error suggests that the sensor's circuit signal is stuck in a lean condition, meaning that the sensor is reporting an anomalously low output voltage when the heater for this sensor is powered on. When the Powertrain Control Module, PCM, detects voltage levels that fall below a predefined threshold, it identifies this as an abnormal situation and subsequently logs the DTC. Understanding the functioning of the secondary HO2S is critical, as it plays a vital role in monitoring the exhaust gases post-catalytic converter to ensure optimal fuel combustion and emissions control. Typically, the sensor is located in the exhaust system after the catalytic converter, where it assesses the efficiency of the catalytic converter by measuring remaining oxygen levels in the exhaust. If the sensor indicates that the exhaust is lean consistently, it may lead to incorrect fuel metering and potential engine performance issues. The secondary heated oxygen sensor, or secondary HO2S, is tasked with monitoring the exhaust gases emitted from the engine after they have passed through the catalytic converter. This sensor plays a crucial role in understanding how effectively the catalytic converter is functioning and how well the engine is burning fuel. By assessing the oxygen content in the exhaust gases, the secondary HO2S feedback is used by the PCM to adjust the air-fuel mixture for optimal combustion efficiency. Specifically, if the measured voltage from the secondary HO2S is consistently low when the heater circuit is engaged, the PCM interprets this as a fault condition, resulting in the storage of DTC P2270. For this vehicle model, the location of the secondary HO2S is critical, as it is installed downstream of the catalytic converter, ensuring accurate readings of the post-catalytic converter emissions. When diagnosing DTC P2270, several potential causes must be taken into account. A primary suspect is a faulty secondary HO2S itself. Over time, these sensors can become defective due to wear and environmental conditions, leading to incorrect readings and triggering the DTC. Furthermore, issues in the wiring or connectors associated with the secondary HO2S circuit can result in poor connections or continuity problems. These faults could manifest as shorts or opens in the circuit, resulting in inaccurate output voltage readings. Finally, while less common, it is essential to consider the PCM itself as a source of the issue. If the PCM is malfunctioning, it may incorrectly interpret data from the secondary HO2S, leading to erroneous codes being stored and potentially inaccurate performance adjustments. A thorough inspection of all related components is essential for accurate diagnosis. Several symptoms may present themselves when the DTC P2270 is active. The most noticeable symptom is often the illumination of the check engine light, CEL, on the dashboard, which serves as an alert for the driver that a fault has been detected within the vehicle's emission system. As the secondary HO2S plays a crucial role in adjusting the air-fuel mixture, a malfunction may lead to noticeable performance issues, such as a lack of power during acceleration or general rough idling. Furthermore, the vehicle could exhibit increased emissions, which may not only be detrimental to the environment, but can also result in failing emissions testing. Drivers may also notice a decrease in fuel efficiency, as the PCM may be unable to accurately modify the air-fuel mixture due to faulty sensor data. These symptoms can lead to further complications if left unaddressed, underlying the importance of proper troubleshooting. The first step in troubleshooting DTC P2270 involves starting the engine and holding the engine speed at 3,000 RPM. This step ensures that the vehicle is warmed up adequately, which is necessary for proper sensor operation and testing. Once the engine is running at this rate, it is critical to monitor the vehicle until the radiator fan activates. This activation signifies that the engine is reaching its optimal operating temperature, which is essential for accurate readings from the secondary HO2S, as the sensor will yield more reliable data under typical driving conditions. After observing the radiator fan's operation, the engine should be allowed to idle for 2 minutes. This idling period helps stabilize the vehicle's engine operations and prepares it for the next testing phase. Accurate execution of this step is vital to ensure that subsequent readings and tests provide valid diagnostics regarding DTC P2270. The second step in troubleshooting DTC P2270 involves conducting a test drive under specific conditions. It is crucial that during this test drive, the engine coolant temperature ECT sensor 1 reads above 158 degrees Fahrenheit or 70 degrees Celsius, ensuring that the engine is operating at a temperature conducive for the secondary HO2S to function accurately. Furthermore, the transmission must be in drive D mode, and the engine speed should be maintained between 1,500 to 3,000 RPM. Driving under these parameters for at least 30 seconds allows the PCM to gather relevant data regarding the vehicle's emissions performance in a variety of operating conditions. Throughout this process, the Honda Diagnostic System, HDS, must be monitored for the status of DTC P2270. This close observation will help identify if the trouble code still persists or provides additional understanding of the vehicle's emission system performance, bringing crucial insights to the troubleshooting effort. Following the completion of troubleshooting and potential repairs associated with DTC P2270, it is paramount to conduct a final verification to ensure all issues have been resolved effectively. The first task is to confirm that the DTC has been successfully cleared from the vehicle's memory. This can be accomplished by using the Honda Diagnostic System, HDS, to erase the trouble codes and assess whether they return after clearing. After clearing, monitoring the onboard diagnostic OBD status is essential. This will determine if the DTC is triggered again or if previous symptoms are resolved. Additionally, a brief test drive should be undertaken to observe if the vehicle exhibits proper engine performance without warning lights. Ensuring that the secondary HO2S operates correctly in conjunction with other vehicle components plays a vital role in maintaining optimal emissions performance and overall vehicle health. Though not explicitly stated, implementing a regular maintenance routine will significantly aid in preventing DTC P2270 from recurring in the future. One of the primary steps includes conducting regular inspections of the secondary HO2S and its associated wiring to ensure they are in good working condition and free of corrosion or physical damage. Monitoring the condition of the entire exhaust system is critical, as leaks or blockages can affect sensor performance and lead to erroneous readings. Moreover, performing periodic software updates to the PCM can enhance vehicle performance and rectify potential glitches that may inadvertently trigger fault codes. Establishing a vested approach to maintaining emissions-related components not only aids in ensuring compliance with environmental standards, but also promotes the efficiency and longevity of the vehicle. In summary, understanding DTC P2270 is crucial for effective troubleshooting and repair related to the secondary heat and oxygen sensors functionality in the Honda CR-V 2023 and newer models. By following the precise troubleshooting steps outlined, technicians can accurately diagnose and rectify any issues related to this DTC. The importance of the secondary HO2S cannot be understated, as it plays a fundamental role in emissions monitoring and engine performance. Maintaining regular checks and performing preventive maintenance on the emission system are key strategies in avoiding future complications that could arise due to similar faults. Ultimately, ensuring the proper operation of this component will significantly enhance the vehicle's performance, reduce emissions, and ensure compliance with environmental regulations. Please like and subscribe to the channel. See you next time.